Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the Pearson Edexcel International A-Level Chemistry Unit 3 for May-June 2023. Moving on to the first question, it says this question is about two ionic compounds A and B. Compound A is a white crystalline solid that contains one cation and one anion. A flame test was carried out on solid A and a pale green color was observed. They want you to identify by name or formula the cation present in A. Because they say the pale green color, they should be barium 2+. And in part 2, they say aqueous silver nitrate acidified with dilute nitric acid was added to a sample of solid A dissolved in distilled water. This is a test for a halide ion. They say a yellow precipitate is formed, and they want you to identify by name or formula the anion present. A yellow precipitate shows that iodide ions are present because of formation of silver iodide. The next they say give the formula of A. Because A contains barium cation and iodide anion, it's going to be barium iodide. Then the anion present in A can be shown by a different test. They say give a suitable different test with the expected result to show the identity of this anion. Another test to show the identity of iodide, meaning telling it apart from all the other anions, is going to be using or adding concentrated sulfuric acid. There is going to be misty fumes, there is going to be a yellow solid, there is going to be purple fumes, a black solid, a colorless gas with a choking smell, as well as a colorless gas with a rotten egg smell, which is hydrogen sulfide. However, because they wanted us to find something that can identify this as iodide, I ignored the misty fumes as well as the colorless gas with a choking smell. So you could write a yellow solid, purple vapor or black solid, and then you could include the hydrogen sulfide, a colorless gas with a rotten egg smell. That could be hydrogen sulfide gas. Then they say in part B, the solid B is ammonium sulfate. They say give a test with the expected result to confirm the presence of ammonium ion. To confirm the presence of ammonium cation, we need to add sodium hydroxide to the sample, and then we heat. When we heat, a gas is going to be evolved, and this gas turns damp red litmus paper to blue. Then they say give a test with the expected results to confirm the presence of the sulfate ion in B. To confirm presence of a sulfate ion, you could add nitric acid followed by barium nitrate, or hydrochloric acid followed by barium chloride. And if a white precipitate is formed, then that shows that sulfate anions are present. Write the ionic equation for the reaction taking place in B2, and they want you to include state symbols. In this test, barium cation is going to react with sulfate anion. Both of them are aqueous to give you barium sulfate, which is a solid. So this brings us to the end of question 1. Let's continue to question 2. In question 2, they say tests are carried out to identify two liquid organic compounds, C and D. A small amount of phosphorus pentachloride is added to separate 2 cm³ sample of each compound. So they say for C, misty fumes are formed, and for D also misty fumes are formed. So presence of misty fumes with PCl5 shows that these two compounds contain OH group, which could be in alcohols or in carboxylic acids. They want us to identify by name or formula the misty fumes. This is hydrogen chloride gas. In part B, 2 cm³ of aqueous sodium hydrogen carbonate is added to separate 2 cm³ samples of each compound. Any gas given off is tested with lime water. For compound C, bubbles of a colorless gas, and the lime water turn cloudy. Turning cloudy shows that this colorless gas is carbon dioxide, and that could have come from a carboxylic acid when you use sodium hydrogen carbonate. And because there is no change in D, yet we confirm that D also had OH group. This means the OH group here is an alcohol. So they say identify by name or formula the gas produced by compound C. This is carbon dioxide gas. In part C, they say 2 cm³ of Benedict's unfailing solution is added to separate 2 cm³ sample of each compound, and the test tubes are placed in a warm water bath. Now with C, there is no change, meaning there is no aldehyde. In D, there is a positive result, meaning there is an aldehyde. So we know C is a carboxylic acid, but D is an alcohol, which is also an aldehyde. And next they say give the expected observation for the positive result produced by liquid D. They want you to include the initial and final appearance of the contents of the test tube. The observation is that a blue solution forms a brick red precipitate. This is because there is oxidation of the aldehyde to a carboxylic acid. Then they say both C and D have the molecular formula with 3 carbons. They said it used the structure of C and 2 possible structures of D. They want you to use the molecular formula and the results from A, B, and C. We know C is a carboxylic acid. If it has 3 carbons, then this is going to be the structure. Because the carboxylic acid functional group is at the end carbon, so these are going to be 2 other carbons, a CH3 and a CH2. And because D is an alcohol, which is also an aldehyde, the aldehyde functional group is going to be at the end carbon, but the OH group can be on carbon 2 or on carbon 3. Here we have it on carbon 2 and here we have it on carbon 3. So these are the 2 possible compounds. Next, they say some infrared data are given in the table. These are the data we're given. And they say state the wave number range for one peak that would be present in the infrared spectra of both C and D, and identify the bonds responsible for the peak. Because D is an alcohol that is an aldehyde, we're going to have OH alcohol. Because C is a carboxylic acid, we'll have OH carboxylic acid. We'll have CO aldehyde in D. This is going to be missing because there is no ketone. Then we will have CO stretching for carboxylic acid. We will have CH stretching for aldehydes. But this is going to be present in the different compounds like you see D, C, D, C, D. But carbon hydrogen for alkane is going to be present in both because they have the carbon and hydrogen bonds you can see here. In this part, the carbon and hydrogens are going to show up as carbon hydrogen alkanes in both. So this is what I wrote here, CH stretching in alkanes, and this is going to be the range. Next, they say a student suggested that the structure of D could be identified using mass spectrometry because only one of the possible structures of D would have a peak at mass to charge 15. Which of the possible structures of D would be expected to give this peak, and justify your answer? Here I drew the 2 possible structures of D we already identified, and we can see fragmentation here is going to cause a CH3, which is corresponding to mass to charge 15, and therefore this is going to be my compound we are looking for, and that's why I wrote it here as the answer, because 15 is due to a CH3 plus which could be created when fragmentation occurs here. So this brings us to the end of question 2. Let's continue to question 3. In question 3, they say this question is about some reactions of butan-1-ol. They say a group of students was required to oxidize butan-1-ol to butanoic acid, and the students suggested 3 different types of apparatus for this reaction. So we have this apparatus E, we have F as well as G, and they say their teacher told them they should use apparatus F. This is heating under reflux, and they say explain why apparatus E is not suitable for the oxidation of butan-1-ol to butanoic acid. If our aim is to create butanoic acid, then we need complete oxidation. By using E will enable the distillation to occur, so an aldehyde could be collected because there could be some partial oxidation. So I said with E, distillation will take place, collecting butanol, and the oxidation to butanoic acid will not be complete. Then they say give a different reason why apparatus G is also not suitable for the oxidation of butan-1-ol to butanoic acid. G has an open end, and so the volatile substances are going to escape, so oxidation will not be achieved to completion. So I said because G has an open end, both reactant and product could escape. Next, they say explain why in apparatus F the water should flow in from the bottom of the condenser. Flowing in from the bottom ensures that condensation is going to be complete, and this is going to prevent formation of air bubbles. Then next they say state the reaction mixture that can be used to oxidize the butan-1-ol to butanoic acid. This is oxidation of a primary alcohol into a carboxylic acid, and we use potassium dichromate with sulfuric acid. Next they say give the color change observed in the flask during this oxidation. It's going to turn from orange to green. In part B, butan-1-ol can also form an alkene, but-1-ene in an elimination reaction. They say name a suitable chemical reagent to carry out this elimination reaction. Because it's an alcohol being converted into an alkene, we need concentrated phosphoric acid. And then they say give a chemical test, including the expected results to confirm the presence of a carbon-carbon double bond in but-1-ene. Here we use bromine water, and the color changes from orange-brown to colorless. So this brings us to the end of question 3. Let's continue to question 4. In question 4, they say this question is about calcium and calcium hydroxide. A student reacted calcium with water to determine a value for the molar volume of hydrogen at room temperature and pressure. And the procedure was in 4 steps. In step 1, 200 centimeters cubed of distilled water, which was an excess, was transferred to a conical flask, and a small piece of calcium metal was placed in a pre-weighed weighing board, and the board was then reweighed. The calcium was dropped into the conical flask, and a bung connected to a gas syringe was inserted. In step 4, they say the volume of hydrogen collected was recorded. So we can see the setup for the experiment, and the results are presented in this table here. They say the equation for the reaction in the conical flask is as shown here. Calcium, which is a metal, reacts with water to produce calcium hydroxide and hydrogen. State 2 observations when this reaction takes place. Of course, we expect effervescence because hydrogen gas is formed, and because some calcium hydroxide is going to be insoluble, we expect the contents to become cloudy. Next, they say calculate the value of the molar volume of hydrogen under these conditions using the student's results, and give your answer to an appropriate number of significant figures and include units. The mass of calcium is going to be this mass minus that mass, which I did here and got 0.126 grams. And then we find the number of moles of calcium, which is going to be this mass divided by the atomic mass of calcium, giving me that as the number of moles. Based on the equation from the previous page, the mole ratio of calcium to hydrogen is 1:1, so they have equal number of moles. And here they gave us that the volume is 72 centimeters cubed, so I converted that to decimeters cubed by dividing by 1000. And finally, I used the molar gas volume, which is going to be volume of gas divided by number of moles. So this divided by that gave me 22.9 decimeters cubed as my volume. In part B, they say a second student using this method obtained a value of 21.8 decimeters cubed per mole for the molar volume of hydrogen. Calculate the percentage error in the student's value. The data booklet value for the molar volume of hydrogen under these conditions is that. Percentage error should be the error, which is the difference between that and that, divided by the actual value, which of course is the data booklet value, times 100. And calculating, writing my answer to 3 significant figures, I got 8.79%. Give 2 possible reasons why the student obtained a value below the data book value, assuming the method was followed correctly and there was no measurement errors. If there were no measurement errors, it means either some gas was lost or the mass of the solid used initially was not 100% calcium. So I said some calcium could have been impure, meaning maybe an oxide was already present, or some hydrogen could have escaped before placing the bank, meaning some volume of gas was not collected. Then in part C, a third student carried out an experiment to determine the concentration of a saturated solution of calcium hydroxide in water at room temperature. 25 centimeters cubed of saturated solution of calcium hydroxide was pipetted into a conical flask, and 3 drops of methyl orange indicator were added. The procedure was repeated until concordant results were obtained, and the results are shown in this table. State the color change observed in the conical flask at the end point of the titration. Because we used methyl orange and the burette contained hydrochloric acid, the color changes from yellow to orange. And then complete the table and use concordant results to calculate the mean titer. So this value is that minus that, we get that minus that, we get that minus that, we get that, and that minus that, we get that. Concordant results are within plus or minus 0.2 of each other. So this result here and that result there are within that range, and therefore they are concordant, so they are the ones I ticked, and they are the ones I used here to calculate the mean titer. So the mean titer was that plus that divided by 2, which gave me this. Next, they say the reaction taking place in this titration is given here, and they say calculate the concentration of calcium hydroxide solution, but in gram per decimeter cubed. I placed the information given to me from the previous page. I have the concentration and volume of hydrochloric acid, so I can use that to calculate the number of moles. Number of moles of hydrochloric acid is concentration times volume, which is 0.04 times 26.2, divided by 1000, converting this to decimeters cubed, and this is the answer I got. Now, using the mole ratio, which is 2:1, the moles of this are going to be half the moles of that, which is what we see here, and that's the answer. Now, to find the concentration of calcium hydroxide in mole per decimeter cubed, it's going to be number of moles divided by volume, which is the moles calculated here, divide by this volume, but of course, convert it to decimeters cubed. That's why I multiply times 10 power negative 3. To convert from centimeters cubed to decimeters cubed, you divide by 1000. And when I divide by 1000, it's the same as multiplying times 10 power negative 3. Using the calculator, you get this. And then the molar mass of calcium hydroxide is, of course, calcium 40.1 plus 2 of this, which is 17 times 2, and I got that. You also need to remember concentration in gram per decimeter cubed that we are asked to find should be concentration in mole per decimeter cubed times molar mass, which is gram per mole. So multiplying that times that gave me this as my answer, and that is the concentration in gram per decimeter cubed. In part D, they say dissolving calcium hydroxide in water is an exothermic process, meaning heat is going to be released. They say describe what you would see if a saturated solution of calcium hydroxide was heated from room temperature to 50 degrees. Heating an exothermic reaction may not be advantageous in this case because we have seen that this solution is exothermic, so heating will cause the precipitation of more calcium hydroxide. So I said heating leads to less solubility, so solution becomes cloudy because increasing temperature will shift the position of equilibrium towards the endothermic side, so less calcium hydroxide will dissolve. This brings us to the end of question 4 as well as to the end of this paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.